Welcome back, Foundations 10. We're going to look at another factoring topic, that being, what do you do if you're faced with a trinomial where a is not 1? You're going to hear this also referred to as something called method of decomposition. So let's look at an example. If we're given something such as this, where it says factor 10x squared minus 10x minus 21, this is an example of a trinomial where, let me grab a pen here, the a value, this number in front of the x squared, is not 1. There are a couple of different ways to do this. The first one we're going to look at is something called trial and error, or educated guessing. If you're not good with numbers, this likely won't be the way that you're going to choose, but let me show you how sometimes this is by far the quickest choice. This is a trinomial. There are 3 terms, 1, 2, and 3, separated by pluses or minuses. When we did the easy trinomials, we would start by drawing our brackets and filling it in, and we'd start by saying we know that the 2 things at the start of the binomials have to have a product of 10x squared. In other words, what 2 things multiply to make 10x squared? We have some choices. We could go with a single x and 10x. We could switch it around and go 10x and an x. We could go 2x and 5x, or switch that around. Now, it doesn't matter what you pick here, but only one of them is going to work well with whatever other numbers you pick. I'm going to go ahead and speculate that it's a 2x and a 5x. I could be totally wrong. This is trial and error, which means I am prepared to make a mistake and go back and say, okay, oops, what should I have done here? The last 2 pieces of our binomials have to multiply to make negative 21. Now, 21 from our multiplication tables, we know could be 3 and 7. It could be 7 and 3. It could be 1 and 21, or 21 and 1. That's not a lot of different options to pick from, because we're going to have to play here a little bit. The minus tells us that these are going to have opposite numbers, but we'll get to that in a second. For instance, let's say, and I'm going to do this underneath just as a thinking exercise, what if I used 3 and 7? Now you have to think about FOIL. Did I really just guess right in the first try? Cool. Outside is going to give me 14. Inside is going to give me 15. Can I use that to make negative 1? Sure I can. The reality is I just guessed out of all of those combinations the right one on the first try, which is very cool. So I know that this is going to be 3 and this is going to be a 7. I need to get a negative after I FOIL, and I know one of these is going to be positive, one's going to be negative. Let's say I go plus, minus. When I FOIL, this is going to give me minus 14x. Inside is going to give me plus 15x, which together is a positive x. That's not what I want. In my question, I know I need it to be negative. So I know that those 2 signs that I put in here, this plus and this minus, need to be the other way around. Now if I check, and again, make sure you tell me, hey, everything that comes after this is a check. First is going to be 10x squared. I'm just multiplying my binomials, repeated distribution. 2x times 7 is 14x. Negative 3 times 5x is minus 15x. And last is minus 21. Collect my like terms. Does this mirror what my question was? Yes, it does. So I know that that's the right answer. Easy enough. Does this always work? What if I ask you to factor, and let's make my pen a little skinnier here. Instead of that one, what if I gave you factor 32m squared minus 76m plus 45? Now the first thing that I want you to remember is when you see crazy numbers like this, when the numbers are far larger, always ask yourself, first of all, is there a GCF happening here? Because if there's a greatest common factor we can take out, everything after that gets easier. Is there anything that goes into 32, 76, and 45? 45 is the most restrictive of these. I know that its factors include 5 and 9, neither of which will go into 32 or 76, or 3 and 15, for instance. And again, those don't go into 32 or 76. There is no common factor in this trinomial. So now if we're going to continue with our theme here and go with trial and error, we need to think about what makes 32m squared. Well, 32m squared could come from, of course, an m and a 32m. It could come from 2m and 16m, and realize these could be backwards, they could be switched around as well. It could be a 4m and an 8m, or switched around. 45 could come from 5 and 9. Whoops, let's not make that a 59. It could come from 3 and 15. It could come from 1 and 45, and so on. Now realize these could all be switched around. These could all be switched around. That's going to get to where there's a lot of different combinations to check, because there's technically 6 things listed here by the time we switch them, and so on. This is not as good a candidate for trial and error unless you're really good with number facts. This is an example of a time where I would suggest switching to method of decomposition. So let's put that question back here. Let's look at 32m squared minus 76m plus 45. Method of decomposition is something that, first of all, is going to decompose, or it wouldn't be called that. What does decompose mean? If you have a compost pile and it's decomposing, it is breaking down. What method of decomposition does is takes this trinomial and breaks the middle term down into 2 pieces. So in fact, we're suddenly going to have a polynomial with 4 terms to factor, which may sound scarier, but in fact it's easier. Does that mean the math to do this is easy? Not necessarily. I'll be honest with you. Some of you are going to struggle with this. However, it is a way to keep working your way through a question if you simply can't figure out what the factors are going to be. So what's going to happen is the first term is going to sit there, and the last term is going to sit here. The middle one is going to break into 2 pieces, which if we put back together is still negative 76m. How do we find the pieces? To find the pieces, we need to, I need a different color, take 32 and multiply it by 45. This is definitely for many of you going to be a calculator process. 32 times 45 is 1440. Or if we were to break down 1440, we know it's 32 times 45. We need to find a combination of 2 numbers that multiply to make 1440 that, if we add them together, give us negative 76. There's the challenge. Now here's a trick. 32 and 45 will not make 76. They make 77 if we add them together, or if we subtract we get 13. We can't get 76 out of them. We need to mess with these 2 numbers. Now there's many ways to do that. You can just play around with what goes into 1440. What I like to do, because I like a little more method to my madness, is work from here and say, or this number, either or. I look at the 45 and say, hey, I can divide that by 5 very easy in my head and get a 9. Whatever I do to one of the numbers, I'm going to do the opposite to the other. 32 times 5, as I said, this is probably a calculator process, is 160. If I go 160 times 9, I still get 1440. Can I use 160 and 9 to get negative 76? No, still doesn't work. Okay, so now let's try this one. What can I do with 160? Well, I could divide it by 2, and I could take this one times 2, which is going to give me an 80 and an 18. If I multiply these together, I still get 1440. Can I use them to make negative 76? No. So I'm going to try again. Let's divide it by 2 again. And let's multiply by 2 again. 40 and 36. Again, if I multiply them, I get 1440. Can I use them to make 76? Of course I can. No problem. Now, when I go to use them to make 76, I have to pay attention to the signs, because this equal sign is important. I want to keep factoring the same expression that I started with in the original question. Negative 76 can be broken down into negative 40 and negative 36. Notice the m's that stayed with it. If I collect like terms and put this back together, I need to get negative 76m so that I can say this is an equal expression. There's an expression with 4 terms. Now here's where the magic happens. Now it becomes a greatest common factor question. We're going to factor this in pairs. Looking at these two things only, what's the greatest common factor that I can take out of 32m squared and negative 40m? Well, I can take out an 8. That's the biggest number. And obviously there are m's in both of them. M squared and m to the 1. The smallest exponent is the 1. The most I can take out is a single m. Now, what's that leave? After I factor that out, 32m squared divided by 8m is 4m. Negative 40m divided by 8m is minus 5. When you go to do this to these other two terms over here, it's really, really, really important that what you get in the brackets is identical. If it isn't, then this process won't work. What can I take out of minus 36m plus 45 to leave 4m minus 5? 36 divided by 4 is negative 9. The easy way to double check now, negative 9 times 4m is negative 36m. Negative 9 times negative 5 is plus 45. This expression is equal to this one. Again, it looks scary, but in reality, we're almost done. This is really a 2-term expression now. Let's go to one more color. This is a term, and this is a term. And if I look at those 2 terms, they have something in common. They have a GCF of 4m minus 5. And if I take that GCF out of those 2 terms, what's left? 8m minus 9. If I were to distribute this times 8m, I'd get this piece. If I took the 4m minus 5 times negative 9, I'd get this piece. This expression is this factored. How do we check? We could FOIL it all out, and you'll get exactly the same answer. This is perfect. That's what method of decomposition does. Let's look at one more. Let's factor 24x squared minus 108x minus 60. Again, looking at that, big numbers, first thing I better look at, is there a greatest common factor? I could take out a 2. Let's look at what happens if I take out a 2. The numbers get smaller, but you know what? Those are all still even. This 2 wasn't the greatest common factor, it was just a common factor. So I could take out something else and something else. In fact, I could take out another 2. What happens if I take a 2 out and there's already a 2 there? Here's what it would look like. It'd be crazy. But I could do that. Realize that's just a 4. And as I'm writing this, I'm looking at these numbers going, oh duh, I could have took a 3 out of there. Which means really, I should have gone straight to there. What does that mean? I'm going to make this neater because this wasn't really what we're supposed to be learning here. I should have been able to go all the way to there with my common factor. Oops, that's a minus. Like so. All right, greatest common factor out. We're not done factoring if any of the factors factor. This trinomial in here, a is not 1. So I can't just say, well, it's x minus something, x plus something as my binomials. However, I should be able to factor this using trial and error, because how many ways are there to get 2x squared? Well, 2x and an x are my only options. There aren't any other combinations. The same with a 5, there's only a 5 and a 1. 2 and 5 are called prime numbers. If you have prime numbers as a and c in your trinomial, you should be able to use trial and error. You shouldn't have to use method of decomposition. I'm going to show you method of decomp in a second, but let's look at it this way first. For a 5, I've got a choice between a 5 and a 1, or a 1 and a 5, and I need to end up with this negative 9. If I go with the 5 and the 1, 2 times 1 is a 2, 5 times x is a 5. I can't use 2 and 5 to get negative 9. However, 2 and 5 is 10, and 1 is 9, so I know this is the combination I should be using. Because this is negative, I know my signs have to be opposite, 1 plus and 1 minus. Because I need to get negative 9, I know that I want this outside, this negative 10 piece, to be negative, inside to be positive. My answer when I factor, whoops, that's a 12, is 12 times 2x plus 1 times x minus 5. Now, if you had opted to go method of decomp instead, this 12 that's sitting out front has to stay sitting out front. However, to be neat, to organize your work, use some extra brackets. This trinomial inside of here, 2x squared and a minus 5, I need to break down that minus 9x into 2 pieces. And that's a squared. What do I know? I'm going to take the 2 and the 5. I have two numbers that multiply to make 10. They need to add up to be negative 9. I can play with the 10 and say, well, it could be 2 and 5, but I know it's not. These don't break down. Think about it. If these two only differ by 1, odds are I need to use that number in itself. What am I meaning? To get that negative 9x in the middle, I'm going to go minus 10x plus a single x. This is still minus 9x in the middle. I could put this all back together. Now, why have I switched to square brackets? Well, think about my next step. I need to look at those first two terms and take out a common factor. What comes out of both? A 2 and an x, leaving x minus 5. Over here, I need to end up with x minus 5. How am I going to do that? What comes out of x minus 5 to leave an x minus 5? This is really important that you see. To make that happen, I have to take out a plus 1. Why is that important? Don't throw it away, or when you expand to check, it's not going to work. What was common? X minus 5. What was left? 2x plus 1. Now, do I need those square brackets to hold these two together separate? No, I don't. What were the square brackets for? To tie this together as the expression that I was factoring up here. Now that I've done factoring it, I don't need it. Whoops, there's a 1 in there, honest. How would you check that? Remember, take the 12 into the first bracket. Then FOIL. There's my 24x squared plus 12x minus 120x minus 60, which, when I collect those like terms in the middle, that should match that if I've done it right. Sure does. Now, as your page gets messier, remember somebody has to mark this. Take a minute and make sure I can see your answer. Make sure if you've started a check that you wrote check so that I'm not thinking that this is more of your work and all of a sudden here's your answer. And that's not factored. Make sure that I can follow what you've done. There are more examples in your notes as always, and some practice on your in your textbook. Have a go at it, see how it goes. If you need more examples or this makes no sense to you whatsoever, hop on Google Talk and ask good questions. Have a great day, and there's another lesson done.